Our topic today is about brakes. Let us look at functions of brakes. One is to reduce the speed. Then number two is to bring the automobile to a halt. Number three is to prevent a still standing automobile from rolling. We have the requirements of brakes. Application of brakes should bring the vehicle at a relatively quick stop at any type of road, whether it is wet, even, uphill, downhill. Number two, we have a separate mechanical brake is required to hold the vehicle in a position on a gradient. The braking system components must require minimum maintenance. The pedal effort required to produce maximum deceleration should be minimum. The braking system should allow minimum time between application of the pedal effort and actual braking effect of the drum. The braking action should not involve any noise or drift the vehicle away from its desired path. Provisions for quick heat dissipation must be incorporated. A secondary braking system must be incorporated should the primary braking system fail. Let us also look at the principle of brakes. A moving vehicle possesses kinetic energy that is converted into heat energy on the application of brakes. This heat is transferred to the surrounding air. In the simplest form, a brake comprises a stationary brake shoe and a friction lining on it and a brake drum. The road wheels are fixed to the rotating brake drum. The driver applies force on the brake pedal that gets amplified and pushes the stationary shoe to make contact with the brake drum and stops its rotation due to a friction resistance. The system generated due to braking action is proportional to the force that brings the shoe in contact with the drum. Let us also look at mechanical drum brake operation. When the brake pedal is depressed, it pulls operating lever and cam is rotating slightly. The forces the two brake shoes apart until they press against the inside of the drum. If drum is revolving, friction between friction material and inside of the drum resists movement and converts it to heat, slowing the vehicle down. We have the images of the drum brake diagrams. They are clearly labeled. Can go through and look at them. We have also the components of the drum brake. We have the back plate, brake shoe, brake drum, wheel cylinder. Let us look at leading and trailing brake shoes. When the cam turns, one brake shoe is pushed out in same direction as drum rotation. This is known as leading shoe. When brake is applied, drum rotation helps to pull this shoe into harder contact with the drum and increases driver's effort. This is known as a self-servo. The other shoe is pushed against direction of revolving drum and is called the trailing shoe. When trailing shoe is pushed into contact with the drum, the reverse is true. The drum rotation tries to push the shoe away. This result is less braking effort than that provided by the leading shoe. We have a twin leading shoe brake. Both shoes are forced out in direction of normal drum rotation. To achieve this, two expander units are used. Each shoe rests on a separate pivot, the other end being moved by its own expander. Let us look at the advantages of a drum brake. Both shoes have leading shoes self-servo effect which gives greater stopping force. It is also more powerful braking effort. There are disadvantages. Operating mechanism requires two expanders. When reversing, the two shoes becomes trailing shoes, resulting in poor braking performance. We have a friction material. Material used must have the following qualities. good frictional property, wear resistance, heat resistance. Linings were largely made of asbestos, but due to health risks,